if you're going to do this out, we're going to say that x is equal to sine of theta. So if x is equal to sine of theta, what does that tell us dx is? Cosine of theta d theta. Let's get all that in there. So now let's substitute. If we substitute all of this in, we end up with 1 over the square root of 1 minus cosine squared theta. But what is dx? Cosine theta d theta. There are some domain restrictions we need to consider. And some of you also saw this. 1 minus cosine squared is the same thing as... Oh, did I write something wrong there? X is equal to sine squared. Thank you. Yep, sine. Excuse me. Thank you. That would be a problem and would not get us anywhere. 1 minus sine squared is equal to what? Cosine squared. So now we're just doing regular trig reduction here. So we have the square root of cosine squared theta, cosine theta d theta. What does that end up equaling? That's just d theta, correct? And we're looking at the domain restriction. She wrote, Yana wrote up her negative pi over 2 to pi over 2. It's important, but not super necessary to remember, but you need to have that there. What's nice about this, we can now integrate it and we end up with what? Theta plus c. But our original function was in x, correct? If x is equal to sine of theta, what does theta equal? Arc sine of x. So the answer to this is arc sine of x plus c.
Can we just
Make? What was I think the nice substitution you guys came up with was x is equal to what? 2 what? 2 sine theta? Absolutely. Now, you could factor out the 4 first and do some u substitutions. It's going to be the same methodology. This is the most direct substitution you can make. This is the most direct substitution you can make. When you write this out, it'd be really helpful if you made sure when you did this, you wrote it as 2 cosine theta d theta, just to be entirely proper here. You continue the substitution and you do end up with something very similar to what we had before, was arc sine of x over 2 plus c, I think. Arc sine of x over 2. Excellent. Very good job. You have an ellipse and you're just trying to find... Yes, I'll get it. You're just trying to find an integral expression for that quarter. That would be the integral from 0 to 3 over 2, and you need it in terms of y, so you solve for what? Y, you end up with the square root of 9 minus 4x squared dx. So that's one quadrant. So if you wanted the whole thing, you need to multiply by 4. You need to multiply by 4. So this would be absolutely fair game for a multiple choice question on the AP exam. Actually, solving it takes a little bit more work. So it's a little bit more work than a multiple choice generally is, but we would need to be able to do that. That could be a free response question. The first thing to do would be to do the substitution and see if it creates something that's helpful. If you do that substitution, you end up with 9 minus 4 times 3 over 2 sine theta. Let's see what happens. So you had this right here, and it's squared. And instead of dx, what would you have? What would you have? 3 over 2. Exactly. Okay. Let's see what happens here. If you do this out, what do you end up with? You end up with 9 minus 4 times 9 over what? 4 sine squared theta. So some of this, look at this. This is something really, what cancels that's really nice? The 4's cancel. And then what are you left with? The square root of 9 minus 9 sine squared theta times 3 over 2 cosine theta d theta. Why is that actually really nice? What's really nice about that right now? You can take the 9 out. You can pull it out. So what do you end up with out front? Times the square root of 1 minus sine squared theta times 3 over 2 cosine theta d theta, like this. But what is 1 minus sine squared? That's cosine squared, square rooted. So what do you end up with? 3 cosine theta times 3 over 2 what? D theta. So you end up with 9 over 2 cosine squared theta d theta. Now, that is simpler than what we had before, correct? Do you agree that that is simpler than... There are limits of integration here, but they're not those. If you're really careful. What's the thing here that's actually really tricky to integrate if you just don't do a definition? What's the thing here that's a little tricky to integrate? Cosine squared. Cosine squared is a little tricky to integrate. We have done it before, though. We did do cosine squared before. What can you... You can do it with parts, exactly. You can integrate cosine squared by parts. You can integrate cosine squared by parts. The thing that I really want you to latch onto, though, the thing I want you to latch onto is this substitution that Josh came up with, where it ended up being 9 and 9. You had the same coefficient out front, which allowed you to pull it out. So you can use parts to finish this. You can use parts to finish this. It is now